be starting soon our panel on supply chains, problems and digital solutions with our moderators and panelists. Thank you. It's starting in 3 minutes. To start, Libath, I'm our moderator. I'm adding you on stage. Hi, Libath.
Hi. I'm just writing to Virginia in the chat. Here. So I don't know how, but maybe the link.
In the meantime, I'm bringing on stage everybody, our panelists.
People don't hear us yet, right? Or
yes, we are already live
okay.
Indeed. So we have 17 people now listening live.
Okay, great.
Hi, Henrike. Hi, Zehavit.
Hi.
Hi, Pantea.
Hello. Did you find Virginia?
Virginia is here. I can see her. Yes.
I cannot see her. Oh, yeah, she's not joining.
Hi, Virginia. If you turn on your camera and mic, I just invited you on stage. And here is Virginia. Okay, Libath, I will give you a stage. Stop sharing. And thank you very much for being here. Bye.
Thank you, Nadia, and welcome everybody to this panel on supply chains, problems in digital solutions, and how additive manufacturing factors into all of this. I'm Libat Nelson, co-founder of Leolane. We provide software for security and consistency of quality in digital supply chains and additive manufacturing. And I want to introduce our panel, or rather I'm going to let our panelists introduce themselves. We'll start with Zehavit.
Hi, everybody. It's my pleasure to attend this panel. I'm Zehavit Reisin, based in Israel, Vice President at Stratasys. I'm heading the material business for Asia and EMEA, and also the design segment, as we call it, which actually talks about polyjet technology and recently stereolithography as well. So all that is under my roof with a great go-to-market team. And obviously, I enjoy my job and role every day.
Thanks, Zehavit. Henrike, please.
Hi, everyone. Yeah, nice to meet you. My name is Henrike. I am co-founder of Replique, which is an internal it's a venture of the BSF incubator, so currently still BSF, soon to spin out. What we provide, or what we do, is we have a secure platform, a digital inventory where we support OEMs not only to store their digital inventory, but also to fulfill with a large network that is globally distributed of print partners. And we also support in the onboarding process, so qualification of parts for this digital inventory and fulfillment, so really end to end. Looking forward to the discussion.
Pantea.
Hello, my name is Khanshaghaghi. I'm a project leader in business development in Equinor. I'm working in our additive manufacturing group as well. And what I'm very inspired with additive manufacturing is basically how I can use the circular economy approach to unlock the value in the additive manufacturing and the digital inventory. And you know, Equinor is building this digital inventory together with Fieldmade and Shell and Total. So we are really want to transform the kind of digital and the supply chain basically digitally.
And last but certainly not least, Virginia. We can't hear you. Virginia, we can't hear you. No. Try again.
You cannot.
Try to.
And immediately when before entering Remo, please tap your mic and camera.
Yeah, I have the mic. Have mic and
try
camera.
joining again. Oh, I think you hear her. Say something again, Virginia.
Can you hear me now?
Yes.
Yes, thank you.
Okay. Sorry about that. I was saying I'm Virginia Palacios, coming from HP, based in Barcelona. The role I have is leading the product management team for the plastics business here in the company, as well as working with the startups in incubating a new business. So I've been in additive for many years and really seeing how it can help transform how businesses are working and in particular the impact that it has in supply chain. So thank you everyone for joining and looking forward to the discussion.
Great. So Virginia, maybe we'll start with you. I know HP has done a survey of many businesses to see how additive and in particular supply chains have changed post-COVID. Maybe you can talk a little bit about that and also mention some of the specific cases HP has experienced in terms of supply chain problems or failures.
Sure. So we did a survey last year with over 2,000 respondents across Europe, Asia, and North America, and we were pretty surprised by the outcome. 9 out of 10 were really rethinking how they were going to do their supply chain after the pandemic, and up to 60% were considering hybrid model, 52% even a relocalization or moving closer to the consumers, and they were really thinking digital manufacturing would be contributing to their business growing an outstanding 99%. So I think what we will be discussing today is very, very relevant. We have also seen some reports from McKinsey where we are seeing the CEOs are really going to drive the operations agenda in 22. They expect over the next decade the supply chain disruption may impact up to 42% of the profits for the company. So definitely having resilient supply chain is gonna differentiate the business outcomes. I think in HP we have during 2020 and 2021 suffered the same type of challenges than the rest of the companies. For sure, we have had shortages of chipsets and electronic components, and we also have had shortages in labor due to the COVID lockdowns in different parts of the world. So in general, I think we were pretty resilient as a company because in many cases we have dual sourcing, 2 factories that can produce the same product, and then we can modify the plans for each of them. But definitely with the changes on the demand for our products due to the pandemic, we have totally changed our planning process. In the past, we were more pushing the products through different channels and country. We have had shortages of products, so we have been much more proactive in how to prioritize the demand across different product lines. When everyone went into lockdown, we went to consumer products because everyone had to equip their families to work and study from home. When everyone went back to the office, then we prioritize again the business products, and we have accelerated changes that we were thinking even for ourselves, like working from home, the office of the future. We had it like for 2030, and in reality 2020 we were all working from home. So I think it has accelerated how all of us have worked.
Yeah, thank you. I think you mentioned the chip shortage. It's amazing to realize that the chip shortage we're experiencing today is a direct reaction to the first wave of COVID.
Exactly.
In a ripple effect of supply chain failures. It's unbelievable how long and how far these ripples can reach. And you know, and there are a lot of other examples like that. I'm sure all of you can think of some of them less expected than others. So do you have some examples? Maybe Henrike, you're nodding.
Yes, for sure. So one example that really struck me as absolutely unexpected was also related to COVID. A colleague from BSF telling me, oh, it's really giving them a hard time, this COVID situation. And I instantly thought it's about their production. Maybe they have, you know, people on sick leave and they can't produce. But that really wasn't the problem. It was in, I think, April last year. The problem was that they had nothing to put their product in because they didn't get a hold of steel drums. And now steel drums is usually an article that nobody really, you know, thinks of it as special. But if you don't have it, you can't, you know, so to say, pack and ship your product. And the reason for this was that at the time, there was a massive wave of COVID in India, which is where most of the steel is produced. And when you produce steel, you need oxygen. And this oxygen was more needed in the hospitals, of course. So the production of steel was very limited at the time. And this was something where I thought, okay, this is something that, you know, we plan for the worst. We plan for, you know, production schedules and all of this. But it's sometimes the little things that really give us a hard time.
And really unexpected, because that is not something that people would plan on, having a problem with steel drums for materials because hospitals are using oxygen.
Not at all.
Right. Maybe some more examples. Pantea? You're on mute. You're back on mute. Oops. There you go.
Working now? Right.
Yeah.
Yeah, so basically what we have, this is not really related just to the COVID, but it's related to if we are not able to have the material that we want or the part that we want, it can actually stop our production or reduce our production. And you know, when we are talking about the production in oil and gas, we're talking about lots of money. So I can give you one example, at least, that it was related to one of the internals of the mini flow valve were destroyed. And what we wanted to do was, and what had happened normally is that when it's destroyed, then it doesn't really help to flow it in the right way. So basically we have to reduce the production to not damaging the whole system. And in this very specific case, we had to reduce the production by 10%. So we wanted to fix this, and then for fixing that, what we needed is we went to our suppliers to check what is available, what we can do, and we understood that we have to wait for 26 weeks. And waiting for 26 weeks.
Half a year.
Yes. And so it means like 10% of the production. And when we're talking about 10% of the production is around 8,000 barrels. And just imagine with the $70 per barrel, how much we're going to lose. And then what we're doing using additive manufacturing, actually, we were able to part, the internal part, instead. And then it was not just 26 weeks waiting. We had to pay like 130,000 euro for that. But by doing the additive manufacturing, we're able just to spend like 20,000 euro and shortening the period to 2 weeks. So just shortening this period, actually, it worth it for us around 80 million euros just for a very short period of time. And this is a very good example. And this is just one example in one of the field, in one of the platform that we were working. So if you just accumulated the effect of that, it can actually be quite meaningful for the whole production if you're losing, if we can operate it in a better way and stop this kind of failure, how much we can save. And this is just the first effect. And the next effect of that is how much we basically can save CO2, for example, not actually emitting, flaring or stuff like that.
Yeah,
So
that's amazing. Those are numbers. And as you said, it's just one example, but you did mention that one of the things you really need is to have the proper materials. And really, even if we move to a digital supply chain, you get materials, even if we use additive, which still come on a regular supply chain. But, you know, when you use additive, that's a little bit different. And Zehavit, that's exactly your area of expertise.
Sure.
Can you talk about that a little bit?
Yeah, so firstly, when we discuss emergency, when we discuss COVID-19, I think still the benefits of additive manufacturing are very clear, especially when it comes to the materials. And why? Due to versatility. So today you buy a solution with set of materials that fits a certain application. Tomorrow, using the very same materials, you can switch to a different one and have higher utilization. An example that is driven by COVID-19 is, of course, General Motors. It was late 2019 that they purchased 17 industrial-grade FDM printers, set them up. It was all in a very fancy multi-million-dollar facility in Michigan. They even trade 700 employees and suppliers. And it was March 2020 that the government said, General Motors kindly deliver 30,000 units for critical care ventilators. Now, this flexibility with the wide range of materials that are available for additive manufacturing is only possible with additive. And we saw so many examples like that during the COVID. I mean, take a look at APHP, the largest hospital network at Europe. They bought printers. It was quite an amazing deal, 60 units that were set up in 48 hours. It was our office type of FDM line. And they said we need in emergency to, of course, create shields and other necessary items. So it was clear, to me, it was clear that when they are buying it, it's not just such an amount of systems. It's not just for the emergency or the critical cases. And the matter of the fact is that today they are using it in various applications, from tooling to clinical models, you name it, spare parts, whatever, within the hospital. So those two examples tell us that with materials, okay, that fit the applications, we can play with versatility, which provides, of course, to those companies more life, second life, if you wish, by switching to current applications that are needed, of course. But
Yeah, so
Libat, let's not hurry up and think that well, I can switch to any material immediately. Okay, there is a work that needs to be done. Sometimes it takes a couple of good months, sometimes years. For example, when we started to have flying parts for Airbus, okay, more than 1,000 parts, it wasn't just about the fact that interior parts could be printed fantastically with Ultem due to its mechanical, thermal, and chemical resistance properties. That was one side of the story. The second side, and the most important one that made Airbus strategically chose additive manufacturing was all the certifications that came with the materials. Now, these certifications are not just to be done by us as a supplier, but also jointly with the client, i.e. Airbus and their tiers. And it's a process. It's a process that takes months. So within the agility that I described, the materials are taken super seriously from certification standpoint, from compatibility. When we get into medical, it's all about biocompatibility. When we get into mobility, okay, Siemens Mobility, wonderful. They chose Ultem. Why? Because it perfectly fits their railway business, and they could print very low volume of parts. No need for million parts that will take storage. However, we didn't have the certification, which is particular for the European mobility business. We worked on that, and that made the change, of course. Okay.
So really,
it's not a walk in the park.
But once you do get the certification, the same material can be used for different applications and also for different parts. And I think
Correct.
that is some of what mitigates the supply chain problems, as you explained.
Exactly.
And so really, once it takes time and you need to prepare in advance to have the certification, to find out the right material. But once you're prepared, you can be more nimble and more flexible.
The agility is there. Exactly. Yeah.
That's right. Henrike, would you like to add something? I see you nodding.
Yes, I would like to add on that what Zehavit just said, and also I think it was kind of hidden in what Pantea said, and also Virginia. This idea of second supplier is not new, but we can take it a little further if we don't think about just another factory doing exactly the same, but we can think of it as, with additive, we can have a complete different manufacturing technology that follows different rules. And when you have a restriction on a traditional technology, you might still be able to produce an additive. And this is, I think, Pantea, your example was really, really good. You were able to have this part maybe provisionary very soon, and you could save lots of business. But also, Zehavit, your point, you need to think ahead. You can't start qualifying when you're in the middle of an emergency, because then, of course, it will take very long. And this is our main goal or main vision and idea at Replique also, to say, go through your parts and think about which ones you can qualify now for later, and then you have a real second source and you don't run into those emergencies. So I think that's very strong if you want to make your supply chain more resilient.
Can I add one more thing here?
Yes, sure.
I think one thing actually is very important here is, now when we're talking about digital transformation, I think one thing which is very important is to kind of make sure that we have this interoperability between the ecosystem and asset. So basically what is happening actually is that it's a data-driven collaboration between the industry, and basically that make it possible to happen, and that make it possible basically to connect different systems together, to act faster, to be prepared when needed. So it is all about that, how we actually model this, how we make sure that all these are interoperable, basically. So this is basically what we have to think, and then based on that, what would be needed as a digital business model probably for all this to work together.
Yeah, so really what you're talking about is a sort of hot swapping. So and also Henrike mentioned this, when one technology of manufacturing doesn't work, you can hot swap another one if you've prepared it in advance. If you try to do it by the seat of your pants when the emergency happens, that's much harder. Virginia, you wanted to add to that?
Yeah, I wanted to share also a couple of examples, one that was internal, the other external. I think emergency as a word had a very different meaning for everyone before 2020 and after 2020. So before 2020, when we were saying additive manufacturing emergency, that meant, for example, a back to school campaign, a problem with one of the PCs, a connector that we would build in additive manufacturing and save millions of dollars in warranty. And we all thought that that was emergency and that was fantastic. In March in 2020, when we were in the middle of the COVID lockdown, emergency had a very different meaning for all of us. So we put all our engineering to design protection equipment, parts for respirators, splitters, CPAPs. So we were all going through all this certification, approval, qualification, design, like on a super record time. And I think these two examples represent two very different approaches. We had we call it an HP on HP initiative, where we were training the engineers, we were explaining what the additive manufacturing can do, which material you use for what, how you do the design, and then in case you have this emergency, that is this quality control or a last-minute product change that you need to do, and you don't want to delay the product, then everything is ready and you can react very quickly. Like in 48 hours, you can start putting the fixed part in the box. When we took the COVID cases, many of the companies we were working with had not thought about additive manufacturing at all, did have no idea on which were the materials. At the end, there are dozens of materials for additive, but there are hundreds of, if not thousands of materials for traditional. So it's not a one-on-one substitution. So really you need to accelerate the regulations, and maybe in this emergency you would be willing to take some risk. But I think as Zehavit was saying before, going through this process of regulation, qualification with time, with quality is what will make the supply chains finally resilient. And I think what Henrike is doing with this digital spare part platform, this is great that the companies can start thinking that when they have spare parts, they will be using additive potentially to produce them, because then as part of the qualification of the product, they can put additive manufacturing parts, they can pass all the certifications during the development, and then they don't need to have additional cost of qualification before they start. Because in some cases, when we have tried to do additive in a spare, it's like, oh, but now I need to requalify the whole thing. So this will never meet the business case. But if you think upfront during the design, then you can put it as part of your development, and then everything flows smoothly when you need it. So at the end is, you will have emergencies, but plan for them and
exactly proactively.
Exactly. Yes, and let me just add to this, Virginia. So I think if you start designing already your parts for AM to start with, that's excellent. I mean, now we also face, of course, lots of old spare parts that have been designed the way they have been designed. So you need to put maybe a little bit of extra effort into that. But if you start with fresh parts, you can do that, and you cannot just use it for spare parts, but you can also beautifully use it for this market launch ramp-up phase, and then like Libas just mentioned, you can switch directly if you have higher volumes to a different technology and return to it when you're in the phase out. So it's really worth it, I would say.
Yes, so maybe a little bit more effort up front. Go ahead, Zehavit.
Yeah, just one more aspect while we are discussing, this on-demand printing, the customized tools and spare parts. There's another aspect that I think we all think about, and in some companies it's already an integral part of the strategy, which is sustainability and reducing waste, reducing stocks that are not needed. These days I'm investigating a totally different market than where we operate so far, which is the fashion one. Sustainability there is a key thing there. And obviously the fact that with 3D printing, being able to print on fabric, the particular number of, capsules or concepts that are needed without printing or creating items that are for stocks. And by the way, it seems that the fashion market is the second in the world after oil in terms of waste. So there's also the aspect here of sustainability, which I know that in my company, we are placing lots of focus on that, from development all the way to how we recycle cartridges, how we treat everything from environmental standpoint, and of course, the nature of everything is the 3D printing nature of on-demand, onshore printing, and that helps a lot, I think, to drive the whole importance of additive.
Yeah,
Just
I
wanted to
think
highlight
what you're
another
saying
aspect.
about the fashion industry is really because of the nature of the supply chain there, you really get a lot of waste because you have to
Exactly.
push materials, not just the materials, the finished product,
Yes,
all the way
exactly.
to the end before people even consider it. And then as fashions change, as they do, you know, you have all this waste. I happen to know a statistic from the eyeglass frame market. A good brand that is doing very well will scrap or put in the dollar bin or whatever you want to call it, 60%, 60%.
Yes, these are the numbers.
The eyeglass frames produced in that year. So
Exactly.
really, and that's if you're doing well. If you're not doing well, and you know, it's much worse. Think about the waste. For every frame that you buy, there's more than one frame that is going to waste and has already gone through the entire supply chain.
Yeah.
So you've spent the money. It's clearly not very sustainable, not sustainable at all, and you end up with a lot of waste. And I think fashion is the same because the trends change all the time.
Exactly.
That's the reason that
Yep.
there's such high waste. Pantea, you want to say something
Yeah,
real
I
quick
just,
about
since you mentioned fashion, I was actually listening to a podcast related to circular economy and how many of those fashion kind of player in industry are thinking about how they can actually make their product different and more sustainable for future.
Exactly.
But then again, it's not just the producer, but also the end user also have to change the attitude and believe in this. So it's kind of working both ways in my eyes, but at least I saw that there are many companies that are thinking about that, how they can recycle, for example, the material, or how they can offering some of the fixing or changing and things like that, which is by itself it's very interesting. But in fashion, it basically is kind of a luxury problem. You want to go for something in industry, like in oil and gas. Basically, this is about safety, and most of the time we have to change the big thing due to the safety, and this is not available, for example. So it makes it even harder to be sustainable there. If you want, I can give you one example about this,
Yes,
and that's about like we have this. A cabinet, the power cabinet, electric cabinet that keep the electricity in. And this is, we have it in all the installation in all of the field. And the thing is that this normally what is happening, this screw inside that is getting destroyed after several times that use. And the funny thing is that you cannot go to the market and just buy the screws. This is not available. You have to go out and buy the whole cabinet to replace it. So just imagine how much material is going to be used for mining those for the cabinet, transport it, buying, and all the cost of that. And in one case, actually, we were able to 3D print the screws from the POM material and use it there. So we keep the cabinet there, and that saved us not just time, but that saved us for one installation 6 million krona. We just imagine that all of that installation that we have, how much we're going to save. I mean, irrespective of CO2 emission for changing the cabinet itself, we were able actually to save around 100 million krona just by doing that. And this is something that we really need, that this is safety. This is not about the fashion, so it's good to have. We have to have this. So this is, and there is no solution out there. So we have to kind of find our solution. And now it is kind of by itself can become a business case for this. And then saving lots of emission as well.
I think your example is very well taken, because part of rethinking supply chains is also about thinking about repair rather than replace, which of course has an impact on the supply chain. But I think the other thing that we've all been talking about is that supply chains are becoming we still use the name supply chain, but they're not really chains, because we want to be able to hot swap. We want to have a whole network. We want to be able to use differing approaches, not the same approach to manufacturing. And that's a little bit tough to put together, but Henrike, you guys at Replique have done that. So can you talk a little bit about the ingredients that need to come together if you want to put such a supply chain in place?
Yes, indeed. So, I mean, I think the problem with many supply chains is that they are linear, so they're very inefficient, and so what we've put together, as you call it, is to go more for more direct interaction via the platform, because once you have started digitizing your inventory, and Pantea, you also mentioned, earlier, it's data you need to exchange, it's digital business models you need to start, because then you don't need to ship parts. So what we have done is that we've built up a partner network of printers or print partners that are able to print different materials, in different technologies, and they are scattered all around the world. So you don't have to ship something to a central warehouse and then start distributing again and again. But you can directly, once you've qualified in the way that Zehavit has also described really well, if you've really qualified the part and the printing parameters, and if you freeze them, and if you encrypt them, and this is what we do, and you have a network of partners that can really fulfill according to those standards, then you're good to go. You can order it, and that's what we do with Miele, that's what we do with Sienna Guardian. You can, even in the consumer, you can order in the web shop a spare part, and it gets printed by one of those partners. And you can even see to that you don't print it, at the other end of the world, but you print it close to where it's been ordered. So I think this is the first step, and of course, digitization is very important, and this preparing, this qualification ahead of time, and of course, this network, because if you think about it, like, yes, you can build it up yourself, you can have a printer, but then, okay, you can't print everything with one machine, then you need a second machine, then it's all in one location, you have to train people. We heard this also in your example, Zehavit. It's an enormous effort that you have to do as an OEM, and trends change, machines get updated. So I think it's really a great achievement if you can use a network of partners that are specialized in their technologies and that update themselves all the time. So that's
and it's
the idea.
also a faster way to at least to start. And if you decide afterwards to do stuff,
sure, or to combine,
and that's a graduation. It's about exposure, and I think in the past we've talked about this. Even emergency applications have really exposed people to additive, and have really given it some boost. But there's still work to be done. Before we talk about that, I just want to mention to the audience that if you have questions, please put them in the Q&A, and we hope to get to them at the end. But
I just want to mention one thing before you
move
on.
Please.
To build on what Henriette mentioned about the supply network, I think one thing that supply network actually enable us to do is basically to decoupling the economic growth from the use of the material. Because in the linear supply chain, basically what we are doing is overwhelmingly using of material just to produce things, and those parts seated to be weighted. In this network, we are able to use it when we want it, and everybody in the network have the ability to choose it, and the supplier can kind of shift between the end user as well. So one day print something for one end user, one day for another. So basically everybody can grow, but this growing and this economic growth is decoupling from the using all those materials, which is overwhelming in the linear. So I think that's another big aspect of that I think is very important. Sorry that I interrupt you.
No, you're absolutely right, and I think that we touched on that before. Because if you pre-certify and you pre-do the process, you can use materials for different things. You can be very nimble. And if you have this network, you can also be nimble geographically, because one of the things we saw during COVID is if you had two suppliers, but they happened to both be in Wuhan you were in trouble. It didn't help you that you had 2 suppliers.
Right.
But I think it's important to also touch upon kind of what we still need to get there, because these are all excellent goals and we're striding towards them, but we're not there yet. There are things that are missing. So would you like, what you think still needs to be done? Zehavit, you want to start?
Yeah, sure. So firstly, just on the materials front, I think we need to continue and strive for more advanced materials that will have a good common denominator, and then proactively certify, work hand in hand with compliance systems in order to be ahead of the race. Okay. And I encourage more and more teams of products and BUs that are working with me to ensure that we have a representative from the compliance team, so there are no surprises. And obviously advanced properties, it's all about mechanical, it's about chemical resistance, everything that is needed in the world of manufacturing, because we, as well as other companies these days, are pushing strongly towards manufacturing with additive. It's not just the story of rapid prototyping or short production series. This is about the real thing. And obviously, certifications are critical. But there's another front. And the other front is the workflow and how we work with ecosystem. So I'll bring an example that we launched last year. Last year was a year of J55, J55 Prime, quite a unique solution, rotational tray, 5 materials that enable full color, multi-material capabilities, but all for rapid prototyping. And then came the topic, okay, who is going to use it? A designer. Wonderful. Is a designer an operator of a shop machine? No, usually he would sit in an office environment to start with and will work with his maybe SolidWorks, then continue to Keyshot for rendering. And in many occasions, that's where he will stop or she will stop. Or if he would insist to go for 3D printing, he would go through hell. Why hell? Because he would need to hop from different softwares to define, adjust the fabric, go to Rhino, come back to Photoshop, come to us to GrabCut Print, our own software. Multi-step, time-consuming process that I think maybe 2 people in our headquarters could really operate. So that was the first thing that we said, before more materials, before any additional feature, we need to fix this connectivity, this workflow. So someone that is used to work in Keyshot, for example, which is a typical design software, will stay in this environment and will export the file to 3MF file format, which happen to encapsulate not just geometry, but also color, finish, materials, and that will be assimilated immediately or absorbed immediately by our printer. Now, the technical details are not important. The important is to understand that if we want, and I think all of us want, that AM will become more and more accessible. And it's not just about the champion at Volvo or the champion at Ford that knows my solutions upside down. And that's where we need to simplify solutions, connect more. This 3MF file format, for example, it's a consortium. Stratasys took part of it, obviously influenced how it will look like. And that's how this connectivity became so smooth. So
Yes,
this is where we need to do, and that's all the way in manufacturing. I don't need to talk about Industry 4.0 connectivity,
yeah.
of course. Yeah.
I think actually it's really important to have this end-to-end platform, because, as you said, 3MF embodies a lot, not everything, and there are even some things that need to be done in conjecture with manufacturing. Maybe Henrike can speak about it in a minute, but I see that Virginia wants to say something. Go ahead.
Yeah, I wanted to add a couple of things. I think those are very good points. I think it is also important that the designers understand how to design for additive to take the advantages of manufacturing, of additive. As Henrike was saying, if you have design for traditional, you will not get the best out of additive, and economics will will not work. I think there is also a very important thing that we all need to tackle, that is around the repeatability and predictability of the outcome. So if we want to have this distributed network of suppliers and all of them provide the same quality, I think it is very, very important for the OEM to have peace of mind that the part that they will produce is the same, that all the manufacturing equipment that we are using can produce the same output. And this is an area that we are working very hard to make sure that no matter what is the location, no matter what is the operator, the rest of the environment, the outcome of the part is always the same. And I think it's also a matter of economics, how we are gonna work as an industry to really drive down the economics, and everyone plays a part. So there is a part of machine amortization, the productivity, cost of acquisition. There is a big part on materials. And it is true that there are many situational economics, where it's not about the part, but it's all those emergencies that we were saying, is the economics of the whole situation. And if you can put a machine back into production, you don't care how much the part actually costs. But if we want to really go into volume production, we need to drive economics big time, I would say.
Absolutely. Those are excellent points. We're almost out of time, so 1 minute each. Henrike, and last but not least, Pantea. Go ahead, Henrike.
Okay, very short statement. I back up everything that you've said. We need to make it an end-to-end approach and not have OEMs adapt to our systems, but the other way around somehow. But at the same time, I think also what's important is to look at additive manufacturing, not only from a technical perspective, but also have this holistic view in the companies, because supply chain is a very, very large field. And I think that if you just look at it like from your perspective in your little box, then maybe it's not, it's expensive maybe for some, printing costs are expensive. But if you look at it holistically, if you think about all the downtimes and everything that it costs you, external costs or costs that are hardly measurable, like customer satisfaction, then I think this is something that we need to do more and more.
Absolutely. And as Virginia mentioned in the beginning, I think the number was 55% of CEOs are going to take control of rethinking their supply chains. Was that the McKinsey number? This is the time to do it. But there, you have the last leg of what work should we do?
Yes. Now, so one thing I would like to say is that here we are not going to improving the old game. Here we are changing the game totally. So, and in this changing of the game, data actually is playing a big role here. It's a big element of that. And for me, it's like we have to actually shifting from disconnected kind of value chain to the value network. And this is possible only by having a new competitive and digital basically business model, which is everything about this is about how we commercially can make it happen. Then all the different steps actually can follow in a right manner.
Yeah, I think you're absolutely right. And one last thing is maybe a shout out to the regulators to push and assist in this process of moving to digital supply networks and digital supply chains. And as we see, we are very minded to quality, but still, regulators tend to meddle there a lot, and meddle might not be the right word. Maybe pushing and boosting is what we're looking for. So we're out of time, unfortunately, but our speakers will be, at least for a little bit, still in the econ track if anybody has any questions. Thank you all for a wonderful panel. I really enjoyed it. And thank you all participants for being here. Nadia, I will give you back control.
Thank you very much, everyone. And what a great panel. It was very inspiring, very interesting. Thank you all for sharing your experience and insight. I will kick you out of the stage. In the meantime, I will share my screen. And we will resume in 45 minutes. Now it's the time for networking. So take the opportunity to network with these amazing speakers, visit our sponsors. You are encouraged to go to the main stage. The main stage is where we have bigger tables, so that's better for networking. And so we'll meet you there soon. Thank you, everybody, and see you at 1:30 p.m. Central European Time. And if you are from joining from US, that's probably very early, but Beijing time is still 8:30 p.m. So see you all later. Bye.